Students, so far we have discussed the definitions of one-one function and onto function. Today in this video we will consider some functions and check those functions for their one-one and onto property. First we start with a simple example of a function which is f is a function from the set of natural numbers to the set of natural numbers defined as fx is equal to twice x. So this is one simple function f, that is a function from the set n of natural numbers to the set n of natural numbers, and this function is defined in this way, fx equal to twice x. So before going to the proof part, let us explain this function. Here you see this is our domain which is n, and this will be our codomain which is again n. As we know that the domain n contains the natural numbers 1, 2, 3, 4, 5 and so on. Here also this codomain n will contain the natural numbers 1, 2, 3, 4, 5, 6 and so on. So here the first set is our domain and the second set is our codomain. Now according to the definition of this function, x will have image twice x. So in place of x, if I take 1, then by this definition 1 will have image 2, 2 into 1 is equal to 2. Then for 2, the image is obtained as 4, 2 multiplied by 2 is equal to 4. For 3, we get the image as 6 and so on. So from this diagram, it is clear that distinct elements from the domain have distinct images in the codomain n. Therefore, this function is 1, 1. F is 1, 1 from this diagram. I think you have understood whatever has been explained here. In the domain, we have seen that distinct elements have distinct images in the codomain. So why this function is 1, 1. Then you see for the onto part, we have seen that you see this one 1, 3, 5, 7, etc. All these odd numbers in the codomain, these odd numbers, they do not have pre-image. These odd numbers in the codomain, they do not have pre-images in our domain. Okay? Therefore, in this particular case, the range is what? Range is the set consisting of 2, 4, 6, 8 and so on, and the codomain is what? N, the set of natural numbers. We have seen that range is not equal to codomain. Therefore, our conclusion is that the function cannot be onto. Now, how can we write down the solution for this particular function? Okay, as we know, we just recall the definition of a one-one function. A function is 1, 1. A function is 1, 1 if for x1 and x2 from the domain fx1 is equal to fx2 implies that x1 is equal to x2. You see, this is the definition of a one-one function. Whenever we take two elements x1 and x2 from the domain, and if we assume that these two elements have the same image, that is fx1 equal to fx2, if it implies that x1 equal to x2, then we can say that the function is 1, 1. Now here, following this definition of a one-one function, for this given function also, what will we do? We will take two elements x1 and x2 from the domain n. Here you see the domain is n. Therefore, what we do? Solution. Let x1, x2 belong to n. Here note that this n is our domain. This n is our domain. x1 comma x2 belong to n be such that fx1 is equal to fx2. We have assumed that these two elements from the domain, they have the same image. Now using this definition, which is fx equal to twice x, I will try to prove that x1 equal to x2. Now see, you look at this definition, here it is given that fx equal to twice x. So clearly fx1, this would be equal to how much? 2x1 is equal to, and fx2, this would be equal to 2x2, and this would imply that x1 equal to x2. Therefore, we have seen that fx1 equal to fx2. This implies x1 equal to x2. Therefore, f is 1, 1. So this is the formal proof that the function is 1, 1. I think you have understood how can we establish that the function is 1, 1. We have taken two elements from the domain, assuming that these two elements have the same images. We have proved that the elements are same, that is the function is 1, 1. Now regarding the onto part, to check whether the function is onto or not, firstly write down the range here. Here range of f is equal to 2 into 1, comma 2 into 2, comma 2 into 3, 2 into 4, and so on. Because once again you look at the definition of the function, the definition is fx equal to twice x. Here x will come from the set n, therefore x will take the values 1, 2, 3, 4, and so on. So in this way we can have twice x, the images is 2 into 1, 2 into 2, 2 into 3, 2 into 4, and so on. So these are the images for this function f. So this would give us 2, 4, 6, 8, and so on, which is not equal to the codomain, because as you know that for this function the codomain is n. We have seen that range of f is the set of all even natural numbers, but this set is not equal to our codomain, therefore f is not onto. Here the function cannot be onto because in the codomain n, all the odd natural numbers, because you see here the range contains only even natural numbers, means in other words, in the codomain all the odd natural numbers will not have any pre-images in our domain. Therefore, this function is not an onto function. However, this function is a one-on function. Next, we will consider one more function, another simple function. This one, f is a function from R to R defined as fx equal to twice x. Here the definition is same as the last one. However, here domain is R and the codomain is R. In the last function, we have considered the domain as n and the codomain as n. But here our domain is R and the codomain is R. Now we will try to check whether this function is 1, 1 or not. So as usual, what we do? We take two elements. Let x1, x2 belong to R, which is our domain. So this is our approach to check whether the function is 1, 1 or not. So following the approach, we have taken two elements x1 and x2 from the domain be such that fx1 is equal to fx2. Now see, the definition here is fx equal to twice x. This is our definition of the function. Therefore, fx1 would give us 2x1 and this fx2 would give us 2x2. That is x1 equal to x2. Therefore, we see that fx1 is equal to fx2. This implies that x1 equal to x2. Therefore, f is a 1, 1 function. This function is 1, 1 because it satisfies the definition of the 1, 1 function. fx1 equal to fx2 implies that x1 equal to x2. Then we check whether this function is onto or not. Okay. Now you look at this diagram. This one is R, the domain of the function. This one is again R, which is the codomain of the function. Now see, suppose I want to check whether every element in this codomain has pre-image in the domain or not. So if every element in this codomain R has pre-image in the domain R, then our conclusion is that the function is an onto function. Okay, let us see now. Suppose I want to take here 1 and I want to get the pre-image of 1. So clearly the pre-image, it has to be half, because then only our function is what? Fx equal to twice x. Then only we get 2 multiplied by half is equal to 1. Means whenever I take 1 here, our pre-image has to be half. So that 2 multiplied by half gives us the image 1. Suppose I want to get here, say 6. Say 6. And I have seen here that to get 6 as our image, I must take here 6 by 2, which is 3. Then only 2 multiplied by 3 will give us this image 6. Means anything you take from this codomain, you divide that particular number by 2, you will get its pre-image in the domain. Means if I take y here, then there will exist y by 2 in this domain, so that 2 multiplied by y by 2 is equal to y, which is the value of image we have considered. Therefore, it is seen that corresponding to every real number from the codomain R, if that real number is taken as our y, then we get some y by 2 in the domain whose image will be equal to y. Means here the function will become onto. Now let us write down the solution here. Let y belongs to R, which is the codomain, be such that y equal to fx. We have assumed that y is the image of some x. Now our aim is to check whether that particular x belongs to our domain or not. Then put the value of fx here. Y equal to how much? Fx? Fx is twice x. This gives us x equal to how much? Y divided by 2. Now see, x equal to y divided by 2, as already we have explained in this diagram, that corresponding to any y in the codomain, there exists some x equal to y divided by 2 whose image under this function f will be again y. Therefore, for any y in R, which is the codomain, there exists x equal to y divided by 2 in our domain, such that fx is equal to, you put x equal to y by 2 here, y divided by 2 is equal to, as you know that the definition of fx is twice x, therefore f of y by 2 will be equal to how much? 2 into y by 2 is equal to y. Therefore f is onto. Means from this it is clear that if you take any element in the codomain, you divide that element or that number by 2, you will get its pre-image in the domain. Therefore this function satisfies the definition of an onto function, and hence it is an onto function. So this is all about this function f from R to R defined by fx equal to twice x. I think you have understood the explanation. Then next we take another simple function. I want to take one simple function, that is f is a function from n to n defined as fx equal to x to the power 2. So this is another simple function, and I want to check this function for one and onto property. Now before going to the solution, I want to explain what is happening for this function here. You see here the domain is our n, which is the set of natural numbers, and again the codomain is n, which is the set of natural numbers. The function here is our f, defined as fx equal to x to the power 2. So whenever I take 1 here, this function will give us image 1 square, which is 1. Image of 1 under this function f will be equal to 1. Now suppose I want to take 2 here. 2 will have image 2 square equal to 4. Then you take 3 here. This 3 will have image 3 square equal to 9, and so on, etc. Now from this diagram it is clear that distinct elements in the domain n, these 1, 2, 3, 4, all these are distinct numbers. Distinct numbers in the domain have distinct images in our codomain. No two different elements have the same image, therefore this function is clearly 1, 1, because distinct elements in the domain have distinct images in our codomain. Therefore it is a 1, 1 function. Then you see, I want to check whether this function is onto or not. Here see, this is our codomain n, that is our codomain, and as you know that n contains 1, 2, 3, 4, 5, all these natural numbers. And what are the images? We have obtained 1 as our image, 4 as our image, 9 as our image, and so on. Means all the perfect square natural numbers. 1, 4, 9, then comes your 16, then comes 25, and so on. All the natural numbers which are perfect squares, all these numbers are only the images for this function f. Means, see, this n contains 2 as well. It contains 2 as well. 2 belongs to the natural number, set of natural number. But 2 does not have any pre-image in this domain because there is no natural number whose square will be equal to 2. Similarly, again you see 3. 3 belongs to this codomain, but there is no natural number in our domain whose square is equal to 3. Means these numbers are left with no pre-image in our domain. Therefore, this function cannot be onto function because here the range will contain only the elements 1, 4, 9, 16, 25. Means all the perfect square natural numbers. However, the codomain is n. These two sets are not equal. Therefore, this function is not what onto. This is not onto. However, this is a one-on function. Now, regarding the proof, as usual, what do we do? Let x1, x2 belong to n. And as you know, this n has to be the domain of the function. Be such that fx1 is equal to fx2. We have assumed that these two elements in the domain have the same images. Fx1 will clearly imply that x1 square is equal to x2 square. And if I take square roots on both sides, we will have x1 equal to plus minus x2. We have two results. One is that is x1 equal to x2 or x1 equal to minus x2. But you remember that this x1 and x2 are from the set of natural numbers. These numbers cannot be negative. Therefore, this is an impossible result. This is not possible. Because whenever x1 and x2 are two natural numbers, we cannot have x1 equal to minus x2. Therefore, we have to take this one. Therefore, x1 equal to x2. Therefore, we have seen that fx1 equal to fx2. It implies what? x1 equal to x2. And hence, f is a one-on function. F is one-on function because it satisfies the definition of a one-on function. And then for the onto part, simply what we do? We find out the range and we saw that the range is not equal to the codomain and our work is done. Range here, range of f. Range of f is clearly 1 square, 2 square, 3 square, 4 square and so on. Because this is the definition of the function fx equal to x to the power 2. For x, I have to take the natural numbers starting from 1, then 2, then 3 and so on. So this is the range and this is equal to 1, 4, 9, 16 and so on, which is not equal to n, which is the codomain. Therefore, f is not onto. So whenever we write that range is not equal to codomain, it means that there are some elements in the codomain which do not have pre-images in the domain. These two statements have the same meaning. Range is not equal to codomain means there are some elements in the codomain which do not have preeminence in the domain. So this is all about for this function f n to n defined as fx equal to x to the power 2. Then I want to go to the next question, next function, and I want to replace this n by z for this function. Means keeping the definition same, that is the definition is fx equal to x to the power 2, keeping this same, I have just replaced n by z for this function. And I want to check whether this function is 1 or not. Now see, here our domain is the set of integers which is z. And as you know, z contains the natural numbers 1, 2, 3, 4, 5, 6 and so on. Z contains 0 and z contains -1, -2, -3 and so on. Means, suppose this is our z. It contains -1, -2, -3, -4 and so on. It contains 0. It contains 1, 2, 3 and so on. So this is our z, which is the domain of this function. Again the codomain is here again z, and the function is here f defined as fx equal to x to the power 2. So remember that this is the definition of the function. Means whatever value you take for x, this will give you the image x to the power 2. So clearly you see -1 will have image 1 and 1 will also have image 1, because -1 image is how much? -1 square is equal to 1. For 1 you get 1 square equal to 1. Means these two distinct elements have the same image 1. Similarly, if you notice -2, this -2 will have image 4 and 2 will have the same image 4, because as you know -2 square is 4 and 2 square is 4, means distinct elements have the same images. Therefore this function is not a one-one function. In fact, this is a many-one function, because many elements in the domain are having the same images. So this is all about your one-on part. And regarding the onto part, you see it is what? X to the power 2. As we know that x to the power 2 is never negative. It can be 0 or it will be a positive number, but it cannot be negative. But you see z, which is our codomain, z contains the negative integers as well. Means -1, -2, -3, -4 and so on. So these negative integers will not have any pre-images in this domain. And negative integers and as well as the integers like 2, 3 which are not perfect squares, 5, these numbers are also not having any pre-images in the domain. Therefore, for this function, the function cannot be onto. I think you have understood, because you see for this function, our range will be what? If I take 0 here, 0 will have image 0. Range will contain only the numbers 0, 1, 4, 9, 16 and so on. However, z contains all such numbers. That is, range is not equal to codomain, and hence this function cannot be onto. Now let us try to write down the proof solution. See here, f1 is 1 square, which is 1, and f minus 1 is equal to -1 square is equal to 1. Therefore, we see that f1 is equal to f of -1, but 1 is not equal to -1. See, this definition of one-on function is not satisfied here, because the definition is what? fx1 equal to fx2. It must imply that x1 equal to x2. This is the definition of a one-on function. Here for this particular function, what we have is that we have obtained f1 equal to f minus 1. So this is satisfied. However, the second part, x1 equal to x2, this is not satisfied for this function. Therefore, this function is not 1, 1. And it is already established that this function is not 1, 1. F is not 1, 1. It is done. And of course, you may take some other example. This is known as counter example, and we have taken this example to establish that the function is not 1, 1. You may take like f2 equal to 4, f minus 3 equal to 4, or you may take f3 and f minus 3. Any example will do. Okay? It is not necessary that you should always write down this example only. You may use any example to prove that this function is not 1, 1. So this part is done for the 1, 1 part. And for the onto part, let us try to write down the images, or let us try to write down the range for this function. Okay, then range, you see range for this function, range equal to, so I start, you see z contains 0, 1, minus 1, 2, minus 1, so on. So let us first take 0 square, then I can take what? Plus minus 1 whole square, plus minus 2 whole square, plus minus 3 whole square, and so on. So these are the elements, these are the numbers in the range. Of course, this is equal to 0, 1, 4, 9, 16, and so on, which is not equal to z, which is our codomain. That is, for this function, we have seen that the range is not equal to codomain. Therefore, f is not onto. Therefore, this function is not onto because we have seen that the range of this function is not equal to the codomain. Okay, I think you have understood this one also. Then I want to replace this z by r. Next example, I want to take this function. What I want to do? I want to replace this z by r with the same definition. That is, our next example is a function from r to r with definition as fx equal to x to the power 2. So this is our next function, and we want to check whether this function is 1, 1 and onto or not. Now see, here also it is almost to some extent similar to the last one. Here the function has domain r. As we know, r contains both positive, negative and 0. Positive numbers are in r, the negative numbers are in r, and the definition is what? Fx equal to x to the power 2. So here you see f half. This is the only difference. In the last example, this was z. Therefore, in that particular example, we cannot take half. But here, since it is r, we are free to take any fractional number here. So f half will be equal to half square, which is 1 by 4. And I want to take minus half, equal to minus half whole square is equal to 1 by 4. Now see here, f half is equal to f of minus half. This is satisfied, but half is not equal to minus half. Therefore, f is not 1, 1. This function cannot be 1, 1 because fx1 equal to fx2 for this function. But however, we cannot have x1 equal to x2. x1 is not equal to x2 for this function. Therefore, this function is not 1, 1. You are free to give any example except this one. You may take 1 by 3 and minus 1 by 3. You may take 1 and minus 1 as well. So this is all about for the 1, 1 part. Then you see for the onto part. What will you do for the onto part? Okay. Now see fx equal to x to the power 2. This x is a real number. And our common sense says that the square of any real number is always greater than or equal to 0. Square of any real number is always a non-negative quantity. It may be 0. It may be 0. See, if you take 0 here, 0 square will give you value 0. Otherwise, irrespective of the values of x, be it positive or be it negative, always that particular value will be greater than 0. Means fx is greater than or equal to 0 means what? Range is the set consisting of all the real numbers starting from 0 up to infinity, any real positive number. Okay, so this is the range which is not equal to codomain r. This is not equal to codomain r. Therefore, f is not what? Onto. This function cannot be onto because here we have seen that range contains only non-negative real numbers. See here, this is the domain, this is the range. You see minus half is there in our codomain. Okay, but this minus half cannot be the image of any real number in our domain because there is no real number whose square gives you value minus half. Is that clear? Means there is no real number x whose square will give you minus half. Means here all all the negative real numbers will not have any pre-image in our domain. Therefore, this function is not onto. So this is all about this particular function, which is f, a function from R to R, defined as fx equal to x to the power 2. Now, next I want to take one more function, that is f is a function from f is a function from n to n, defined as fx equal to, next function, f is a function from n to n, defined as fx equal to x to the power 3. Okay, so this is a simple function, that is f is a function from n to n, and this is our definition. Now see, regarding the diagram 1, 2, 3 and so on, here also this is our codomain consisting of 1, 2, 3 and so on, and the function is here f, so that fx equal to, we have what, x to the power 3. Clearly see, 1 will have how much image? 1 will have image not 8, 1 will have image 1, because the function is what, fx equal to x to the power 3, therefore image of 1 will be equal to 1. 1 cube is equal to 1. Then we go to 2. 2 has image how much? 8, because we know that 2 cube equal to 8. Then you go to 3. 3 will have image how much? 3 cube equal to 27. 27 and so on. Means we have seen that distinct elements from our domain have distinct images in our codomain. Therefore, f is 1, 1. F is 1, 1. This function is 1, 1. And this function is not onto, because see here our range. What is the range here? Range is 1, 8, 27 and so on. This is our range, which is not equal to the codomain. Which is not equal to the codomain n. Range here is not equal to the codomain. Means there exist some numbers in our codomain n, such as 2, 3, 4, 5 and so on, which are not images of any natural number in our domain. Therefore, this function is not onto. Dear students, I think you will be able to write out the solution in a systematic way for this particular function. And the last one, you complete this one at home. You try to prove that this is a one-on function by taking two elements x1 and x2 from its domain n, such that fx1 equal to fx2. And then you establish that x1 equal to x2. In that case, the function will become 1, 1. And for onto part is already done. Range is this one, which is not equal to the codomain. Therefore, this function is not onto. And the last one, f is a function from z to z. F is a function from z to z, defined as fx equal to x to the power 3. This is another simple function which is from z to z, defined in this way. And this function is also, I think it should be a one-on function, because see here z, if I take minus 1 here, this would give us value what? Minus 1, because minus 1 to the power 3 is minus 1. If I take suppose 2 here, 2 will have image what? 8, because 2 to the power 3 equal to 8. Suppose I want to take 1 here, 1 will have image 1 and so on. So in this way, it can be observed that distinct elements from the domain will have distinct images in our codomain, so that the function is a one-on function. And for the onto part, what you do, you find out the range here. For this function, you find out the range. Then you show that that range is not equal to our codomain z. Therefore, this function is not onto. Dear students, in this video, we have taken some simple functions and we have discussed how to check those functions for their one-on property and for their onto property. I hope you have understood all these discussions, all these explanations. So thank you.